very warm welcome. Before we start our webinar, just like to remind some etiquettes. Kindly use the QA icon on the tool if you have any questions to the panelist. We are recording this session and we'll post this on our YouTube channel, Asian Institute of Design YouTube channel, and you could refer back at any time you wish to. So hope you will have a very interesting and meaningful session today. Before we start the program, let me provide a brief introduction who we are and what is this Asian Institute of Design and Aided Learning Platform is all about. Asian Institute of Design is an higher education institution in Bangalore, India, which offers primarily bachelor's programs and professional diplomas in the field of gaming, animation, game design, game development, uh, also in technologies such as artificial intelligence, data science, and design such as user experience design, graphic design. Owing to the kind of courses what we offer, our faculties are generally drawn from industries across, well-known studios in and out of India, and the kind of focus is mostly on pedagogical approaches on student-led learning, where students generally focus on developing their cognitive skills by doing a lot of activities. So our alumni are working across major studios in the world, and a lot of credits in movies like Jurassic Park, Godzilla, also Red Dead Redemptions, Grand Theft Auto in the AAA rated games. So the kind of work they have done and the credits they have itself validates the kind of teaching and learning pedagogical approaches what AAD focuses generally on. So if you wish to know more about us, or kindly follow us on our social media handles on YouTube, Facebook, Instagram. Uh, Before we move to the webinar itself, let me just talk brief about aided learning platform itself. Uh, when the pandemic started, everybody were migrating towards online teaching and learning. But Asian Institute of Design felt that it is not just the online teaching and learning in the college level, but how can we bring the academia and industry across the globe under one platform with a basic objective of knowledge for everyone. So through this aided learning platform, we have been successfully doing webinars and discussion sessions, and this is the fifth in that series, which focuses on virtual lab, which is very much relevant with the current scenarios of teaching and learning process going through online. Uh, Under Asian aided learning platform, Diesel is the one consortium which has supported us a lot in bringing up this content and the courses or the webinars online. And Diesel is a consortium of European Union universities and Indian universities with the sole intention of creating content or the courses that focuses on skilling and reskilling the youths to be more employable and meeting the labor market requirement. So we have partners from Indian Institute of Technology Madras, IISc, Amrita University, Symbiosis International University Pune from Indian partner side, and Obrial at Global Observatory, KTH Sweden, TU Berlin, and University of Lisbon. So these are the partners who have come together with the sole purpose of skilling and reskilling and making sure that the youth get what they require to be more employable and more meeting the industry requirements. So in support of Diesel, we have started with this webinar series, and for the today's webinar, which is basically on labs have landed on the moon. That is, most of the courses are being delivered online, but how do we support the students' practical aspects, the courses which require practical components and the lab developments? So how the virtual labs have really supported in making this teaching and learning more interesting among the students. So we have eminent panelists today who would be sharing their experiences and the knowledge, how they have incorporated or built virtual labs in their universities and the And among them, we have today Professor Gangadharan from NITK Surathkal, India, Miss Birte Heinemann, a PhD student from RWTH Aachen University, and Mr. Thuvishan, who was a global digital product specialist at Quanser, Canada. So I extend a warm welcome to all the panelists. Along with that, today's session is being moderated by Professor Rajeev, who was a professor at KTH, the Royal Institute of Technology, Sweden. He is a professor in electrical power engineering and design, and also is the director of research centers, Vigrids, and director of international relations for Indian operations. Uh, so his PhD in electrical engineering and his focus areas are on electromagnetic compatibility, lightning protection, along with strong interest in pedagogical approaches. So I believe the session would be very interesting with Professor Rajiv taking up the moderation and coming up with the kind of questions or sharing his experiences along with the panel members, which will be very enlightening one for you all. And hope you will have a very interesting session and more knowledgeable one, which you can share it to your colleagues and students over your colleges and universities. Thank you all for being part of this webinar. And I now hand it over to Professor Rajiv. Thanks a lot, Professor Rajiv, to accept to be moderator. And over to you now.
It is a pleasure to welcome all the speakers here today. We have Dr. K.V. Gangadharan, who is professor in mechanical engineering and head of Center for System Design at National Institute of Technology, Karnataka in Surathkal, India. And we have Ms. Birte Heinemann, who is a PhD student at RWTH Aachen University in Germany in the Learning Technologies Research Group. And we have Mr. Thuvishan Rajagulasingam of the Global Digital Product Specialist at Quanser, Ontario, Canada. So we have all three continents represented here among the panelists. Now, the flow of time will be somewhat like this. First, each speaker will present 15 to 20 minutes of their research related to the virtual labs. And after the presentation, we will have a discussion session and also questions to the speakers. So now I will call upon Dr. Gangadharan. So I will give you a brief introduction to him. So he is professor in mechanical engineering and head of the Center for System Design. And he has earned his PhD from IIT Madras in the year 2001 in the area of railroad vehicle dynamics. His areas of research are system design, vibration and its control, smart material and its application, structural health monitoring and product design. He is also actively engaged in creating learning materials for experiential learning of basic concepts in engineering. And he has research and teaching experience of more than 27 years. He is also an active amateur radio operator and in charge of the amateur radio facility at NITK Surathkal. I also have to say that due to some technical reason, Dr. Krishnashree from Amrita University was not able to participate in today's speaker list. And very sorry about that. So first, Dr. Gangadharan, you're welcome.
Very pleasant good afternoon. Hope I am audible.
Yes.
Okay, thank you. So, welcome the team from AID as well as the panelists for an exciting journey of being virtual in the real world. So, we should see how we are able to perform our teaching and learning in this virtual world as realistic as possible. So that's what we are trying out. I know all academicians are now working overtime to make sure that we provide the same kind of feel and experience to our learners. So let us see what Indian government has done in order to create such a situation in this difficult time. So I just present my screen. So on behalf of National Institute of Technology, Karnataka, Surathkal, we welcome you for this program, wherein few minutes we'll discuss about what Government of India have done in order to create situations like this, making pleasant and presentable for the learners. So if some of you have not visited NITK, I can only allow you to have a virtual tour, vtour.nitk.ac.in. You can very well see after the webinar to get the look and feel of what NITK is all about. Today, the Government of India's initiative about experiential learning and providing online tools for experiential learning is what we are looking at. Okay. As Professor Rajeev mentioned, I am KV Gangadharan from Center for System Design at NITK Surathkal. All of you just imagine, we take someone for 4 years or 3 years and teach them everything which is required for riding a cycle or swimming in a pool or a river by making them sit outside and make them read books, make them solve problems on floating body, read them, ask them to do dynamic analysis of a two-wheeler and how we balance in a two-wheeler, etc. And for 3 years or 4 years, we do this. At the end, we ask them to do either cycling or swimming. I'm sure all of you are laughing at me now when I make this statement. And that is exactly many of us are doing in engineering. Now, can we do engineering rather than read engineering is the question which we have been asking. Let us do engineering rather than read engineering. So we are so good in making people to read engineering, and at the end, we assume that they will perform well as an engineer. So what is that we can do in this difficult time when such situations are there? The question is very simple. We have evolved, but did the gurus evolve? Let us see. I'm sure now presently we are with these kind of gurus, and our jhana goes like this. And our young friends are more worried about the likes and loves they get on their posts. And hence, is it possible for us to make sure that we engage them in the same media? If they are happy with online, can I provide an experiential learning in the online media? I'm so happy that when I heard the introduction about AID, he said the user experience. We are quite often looking at how do we make the user experience quite vivid? And instead of remembering a concept, can I make them experience the concept? So whenever we think about experiential learning, I'm sure all of you get tempted to think in this way. And you do something with hand. And of course, once you do that, be ready for this. Then one way out is get into the dumb box and sit in front of that and try to create a similar environment where experiential learning can be done. So that's what we are looking at. Now let us now specify what is that we need. What is that we need to make sure that we are providing experiential learning. Now, present situation, all the teachers, if they go and ask their administrator about provide me additional funding for something, obviously they are going to raise their eyebrow. And as the teacher, they are already pushed to the side to an unknown domain or terrain where they have to talk to the screen and smile at the screen, expecting the response from the students on the other world. And our smart students, obviously, they are happy to be online. They want to know how they can make use of this online activity to the best of their ability and to make sure that they are able to advance from this online activity. So let us see what each one of us are looking. Administrators required low cost or no cost solution, and the faculty members are looking at not too much of new learning to use a tool, and the students want to do many things online. So let us imagine what specifications we will provide for such a system. I'm looking at a learning management system and a lab which provides an experiential learning. I want it at my place. Wherever I am locked down in this COVID situation, I want it at my place. I want the learning management system and the lab at my pace. I may be a fast learner. I can manage 2 concepts, 3 concepts quickly. Or I'm a slow learner. I would like to go through a concept or an experiment thrice or 4 times so that I get it completely right. And look at our student crowd. They are so active after midnight, 12 o'clock. Assume that after midnight, 12 o'clock, my students want to do an experiment. Don't ask me what experiment. Okay. So we would like to do learner to do an experiment or concept visualization at their time, at their pace, and at their place. So this is our first requirement. Then we would also like to have this facility which can be taken home or it should be carried with them. Obviously, we don't want a lock and key for such a lab which we are dreaming, and we don't want any holidays. In fact, all of us have forgotten the holidays now. Saturday, Sunday, and Monday looks almost alike. So a lab with no lock and key, a lab with no holidays is what we are looking at to provide experiential learning. If you look at different universities and different curriculum, the lab should match with the syllabus. And at the end, each of them should be able to get their dream job. Can we think about putting everything required for all this at one place? And that is what exactly Government of India have done with an initiative from Ministry of Education. Its old name is Ministry of Human Resources Development, under a national mission on education through ICT, wherein 12 institutions came together, 5 old IITs, then few other institutions, including NITK Surathkal from Karnataka, came together to create virtual lab which can provide experiential learning for basic concept in engineering and science. The concept is very simple. Provide the modeling and simulation based labs one way, or conduct n number of experiments and save the data. And when the student come online to do an experiment, he does the experiment in simulation, but provide him the data which is acquired from actual experiment. Or the king of all the virtual labs, which is remote triggered lab, wherein an actual experiment we provide them for the user to trigger and play with and get the data from it. And all these are virtual labs. At Indian condition, it is vlab.co.in, and the remote triggered lab is available at rtlab.nitk.ac.in. At NITK Surathkal, we have set up a center for system design, which is a transdisciplinary research center, which make this virtual lab for the consortium. And all other institutions are also making virtual labs. What I will do is, maybe as I go forward, I will demonstrate few of the labs to get a look and feel. So before we get into the virtual lab demonstration, I would like to show you some quick statistics. Yeah. So this is statistics of lab at NITK. We had, out of all the labs, I have taken 14 labs and just shown here in the one page. You can see the number of users, the number of page views, how it is changed. But this alone may not make much of a difference. I'll show you in the next slide. It is from 1st January 2020. Here, we have mapped it from January 1st to October 27, that is yesterday. You can see the way in which users have been coming and the new users are coming. That means when people have locked down, they are looking more on internet and trying to find experiential learning content. And what Government of India have done is made sure that all these all these virtual labs have the nodal center all over India. And you can see not many places are empty. We have 1,166 nodal centers for virtual lab. And the last year itself, we have conducted 1,598 workshops. And of course, the usage is quite huge. Those who are away from India, these are Indian numbers because India is 130 crore people. So we need that kind of a number to come from. So if you look at the other statistics, each institute, how the virtual lab is performing, we have the page views 3.3 million onwards. We have that kind of a page views, especially during this lockdown period. And we also captured the information which are the branches or streams of engineering which are quite actively pursuing this. How many users, that's what the indication is. And we also looked at the cumulative views and page views, and some of the labs which is actively doing it is also being captured. So let us just look at a demo. I'll just stop this screen and I'll give you I'm just looking at the screen now, which I need. I hope you are able to. Can I get a quick feedback? You are seeing the virtual lab website now?
Yes, yes.
Yeah, thank you. So this is a virtual lab website from Ministry of Education from India. Clearly, the broad areas have been divided and we have put the labs accordingly. And it's available for everyone in the world or the universe, wherever you are with a computing device and a net connectivity, you should be able to use. And India, with its generosity, it is free to use for everyone. So we'll just look at one lab which we have made at NITK so that I can just show you how it goes like. These are the labs, and in that I will just take one lab so that, let me just, so we are looking at a vibration lab because I know it is from AAD can comment on the look and feel. Of course, we are not game designers, but of course, we did conduct a survey among the youth to find out what font they like, what color combinations they like, etc. And if you're not from engineering field, assume it as an car body, which is M1, which I'm indicating here is the car body, and M2 as the tire. So tire is moving as depending upon the road profile. So I want the M1 to be stationary. So I'm going to change few parameters. So to make the student experience what happens when he changes a parameter. Okay, this is the first stage. Please make sure that M1 and M2 are moving together. So I'm changing it a bit again, and I'm going to make another parameter variation. As it is not a subject activity or not a stream, so I'm not going to explain what parameters I'm changing, but in a vibration domain, if M1 and M2 are moving on the opposite direction, so this is in opposite direction, this is a second mode of vibration. Now, if that is possible by a design variation, I'm going to look at a small change in the design and see whether we should be able to get a condition wherein, look at the condition now. The seat where I am going to sit in the car, that is M1, is almost stationary, whereas my tire is free to move as it wishes. It is moving up and down, and this is a condition which we would like to have. So by making some parameter variation much before making it, we are allowing the students to experience the variations. So with this, probably it works much better than the equations. In fact, I teach this subject and I find it very difficult to convince even the smart students and NITK to talk about this big equations and how it is actually working. Whereas after making this, we saw that our ability to communicate and make the student to experience the concept become really good. So from here, we'll just move on to, we are moving on to an experiment, which I like to do on a remote trigger. So here, hope you are able to see the picture here. This is an cantilever beam, okay, and some simply supported beam and other beams are there. So I'm going to connect this and I will trigger this experiment. This is an actual experiment. The student is not going to come to the lab. He is going to just look at the experiment, and this is the actual data which has come from the experiment. Okay. So from here we should be able to do you should be able to calculate the data, calculate the value from here. There are many parameters which can be calculated. You can download the data and make sure that you get a feel of actual experiment. So this is called RT lab, remote triggered lab, wherein actual lab is being triggered from remote. I'll show you possibly another experiment, wherein I'll see whether I can change some parameter. I'm looking at an experiment which is just waiting for the video to come here. Just stop sharing. I have a doubt whether you are getting the one which I am showing. Okay, I hope you are seeing what I am showing here.
Yes.
Okay. Yeah, so I hope you are able to see a video here. What I will do is I'll just connect this. I have time up to 40 seconds. Of course, I am on a queue now. That means another person is using. That is, I'll get that other person removed, because at a time only one person can use. So that means there is somebody else using it. Okay, that was me only. I had triggered it. I had tried triggering it earlier. So it was saying that yes, now I have only 3 minutes and 25 seconds. So I'll do one thing. I'll just trigger this experiment. So once the instructions are given, the simple pendulum is triggered. And once that activities are finished, the data will be gathered, and you can get the experimental data here down. Very similar to the experiment which you have done here. The same kind of data will come. Here again, let us just look at one more experiment trigger here. So if I trigger this experiment again, you can see this is a simple civil engineering problem statement where I just put it down, then hold it for a while, then I just release the beam, it moves like this. Okay, let me see whether this data is taking a little more time to get through. So probably I can show you one more experiment. And similar to the experiments, we also kept Lekhupadas, means in Sanskrit, Lekhupada means very concise descriptions of few of the activities. You can look at the Lekhupada in our website, and it's a very concise way of explaining things. We have made sure that nothing crosses 120 to 180 seconds, and that kind of a concept has been used in order to create Lekhupada. I'm seeing that it's taking more time to load. So it is similar kind of an experimental data will come from the pendulum. And once the pendulum oscillates and finishes, we can change the data, change the variable length. So this is how we had implemented virtual lab. Now, when we look at virtual lab, we provide virtual lab as an experiential tool. And for a teacher, he should be able to use it in the normal classroom or in a virtual classroom. So if somebody wants to teach a concept, and if he has to create his own visualizing tool, it is going to load him a lot. Whereas if someone is able to use some tested and verified item available and provided by the government in Indian scenario, so it can be easily made use. So many of the universities have adopted this. And in fact, we have completed a series of activity with Anna University, Kerala Technical University, as well as Visvesvaraya Technical University in Karnataka. Similar activities have been going around all over India. So this is what Government of India have done to make sure that experiential learning is not getting hampered even during this pandemic. Of course, this was started way back in 2010. That time, COVID was nowhere in the picture, but now it looks to be an apt tool for online education as well as online experiential learning. With that, I'm winding up my session and handing over to Professor Rajeev.
Thank you, Dr. Gangadharan. We will reserve the discussion and question to the end to save the time. The next it will be Miss Birte Heinemann. And Dr. Gangadharan, thank you very much. Ms. Birte Heinemann is pursuing PhD in Learning Technologies Research Group at RWTH Aachen University in Germany. And she has completed the Master of Science in Computer Science from University of Paderborn in Germany and worked there for 3 years at Computer Science Education Department. So she is part of the Digi Lab for You project, where several real laboratories in Germany and one in Italy are digitized and linked together with virtual components. So these laboratory-based learning scenarios are investigated, linked, and researched in reality, remotely, and computer virtually. So this is very exciting. The floor is to you, Birte Heinemann.
Thank you. I will not say these magical words. Let me share my screen. So, thank you for the introduction. It was great, so I can directly start. My focus in the project Digital Lab for You is designing digital lab-based learning environments and implementing learning analytics in these environments. So here's a short overview about the content I want to talk about. First, I want to give you an overview about our project, and then I want to tell you something about integrating learning analytics into it. So, it's not working now. Now it's. So what was the starting point of our project? Industry is affected by digital transformation, and one definition of this digital transformation is the change from physical to the digital world based on information and communication technology. And I want to show you 3 examples to illustrate these changes, and they are in this intersection between research at universities, teaching and learning, and preparing students for their future life, and industry. The first one is smart cities, so building smart buildings in the future. We want to make them smart because smart buildings are sustainable, energy efficient, and they help to save resources. And a variety of sensors and actuators demonstrate to this close connection between the virtual and the real world. And for example, in DigiLab4U, students are involved in experimental installations and research actions of smart city project. It is called the Smart Public Buildings. We also have IoT projects. Here you can see an example of location and context related sensory data, which is conveyed by augmented reality glasses. It shows an example of the transport data logger. It processes the information like inclination of the box, vibration, temperature, and humidity. And the third example is product networking. Its digitalization opens opportunities for product networking, even for universities. And this networking is especially useful where resources are limited. And this is often the case when it comes to laboratory equipment. And this was the starting point. This observations was the starting point of our research project. And we had a lot of questions. We wanted to maximize the output of our laboratory investments. So we asked ourselves, how often are our laboratories used? How much does a laboratory cost per hour of operation? And to be honest, laboratories are expensive and it's hard to keep them up to date. Mr. Gangadharan told you already some great points. He told you about the possibilities of virtual labs. And so I don't want to repeat them now. That was the questions. And then we started our project. It's funded by the Federal Ministry of Education and Research, the BMBF in Germany. And it started in the September 2018, and we are now so in our 3rd year. And to give you an impression of to give you an impression of the size of the project, there are about 600 person months, and our consortium consists of 5 different institutions that contribute to the project from Germany to Italy, and the picture shows you how many persons are nearly involved. It's really slow, I'm sorry. We have different goals in our project. One goal is the clarification of requirements for the teaching in this modern times, and with special regard to laboratory-based research and teaching and engineering sciences. So we realistically wanted to assess the advantages and disadvantages and the costs and benefits of using special e-learning tools and virtual labs. The second goal is the conception of technical infrastructure and didactical design for a network, digitalized physical and virtual laboratory environments, because they're quite new. And we wanted to to integrate learning analytics, serious games, augmented reality, virtual reality, and mixed reality, and other selected didactic concepts in our labs and in our learning environments. And another goal is to develop a sustainable business model, which is based on sharing economy model. So now I talked a lot about our goals, and this is how our lab network currently looks. We are labs, and every partner is contributing with different laboratories, perspectives, and questions. Here are some examples. We have the RFID lab in Stuttgart. We have a gaming lab in Biber, which is in Bremen. We have topics like supply chain management and mixed reality. And we in Aachen here are contributing with learning analytics. Exemplary, I want to explain our laboratories using the RFID measuring chamber in Stuttgart. The chamber is this silver cubus in the picture, and the chamber is an industry-related application. It's a test environment for reading the reading range and 360-degree reading profiles of RFID tags, and RFID tags count to key technologies of modern industry. And our students are learning from hands-on experiences in the laboratory, and this is a central point in engineering education. But they are not only learning to experiment, but also about instrumentation, about teamwork, and a lot of other things. And we can also add more points, which are connected to competencies, so that are important competencies in the modern working world, and we want to also help them to enhance their self-regulated learning and interdisciplinary, for example. We have 3 versions of the laboratory. I want to show you now more about the RFID measuring chamber. We, of course, have the real chamber, but we also developed a virtual and a remote version of the lab, especially to foster digital competencies of lab-based learning, as well as provide lab environments for a cross-institutional exchange. In this context, we want to investigate how learning analytics can be used to support laboratory-based learning and teaching processes. Our next step in our lab, in our project, is to focus on the combination of VR version and remote version. For the lab scenario, we implemented a hybrid learning concept where students work in small groups and with a professor in a plenum, with different phases of this lab-based learning process. I will not go into details. We have typical phases from the instruction to the experiment to interpretation of data and documentation. And in all these steps, we are collecting data which we are able to collect with, for example, to collect in Moodle or in the virtual world. I will now give you a short introduction to learning analytics. So learning analytics in a nutshell. People are in the center of learning analytics. Here is a learner who learns certain context with certain activities. For example, our students are learning in the virtual RFID measuring chamber, and we are able to capture data with this new technology from the students' learning activity, for example, the head movement, or if they walked around in the virtual world. And we also get a lot of different other data, which is logging data, for example. We have some questionnaires, but we also know about how they use video tutorials and if they are hearing the lectures online, and so on and so on. So every data you can imagine, in theory, it's possible to collect it. We store this data in a learning record store. It's data about the learners and the context in which they are learning. So the purpose is to understand and optimize learning and the environment in which it occurs. For example, we are interested in the educational background and student characteristics and their academic performance. The next step is that we use computational analysis techniques from data science, for example, or artificial intelligence to gain insights into what our students are doing when they are learning with our course. The next step is surely to give them feedback. And this feedback we are using to empower learners and to help them to make meaningful decisions and developing self-regulated learning skills. And we also try to improve the teaching efficiency with this. So to sum it up, I'm one slide too far, but we don't care. Learning analytics is a learning-centric measurement, the collection, analysis, and reporting of data about learners and their context. So now we are back in our goal and my goals. We in DigiLab4U, we are teaching and researching, and students are learning with different modalities. For example, they are learning with touch, vision, and hearing, and we want to investigate these different areas of lab-based learning using multimodal learning analytics, and we want to turn data into meaningful insights and actions for them. You already know about the other goals in our project, so to sum it up again, we want to create a sustainable and modern and networked lab structures. We want to enhance engineering education and support the quality of learning and teaching. Here are some videos linked, which will give you more insight and more information about our project. And if you want, you can also visit our project website, which is digilab4u.com. And with this, I hope I'm in time because something went wrong with the presentation mode, so I was not able to see.
Okay, thank you very much, Ms. Birte Heinemann. We were able to see your presentation very clearly. No problem at all from our end. Thank you very much for explaining the work that you and colleagues are doing in DigiLab4U. Now, we have our next speaker. Mr. Thuvishan Rajagulasingam from the company Quanser. He is the Global Digital Product Specialist, Quanser in Canada. Thuvishan holds a Bachelor of Engineering degree in Mechanical Engineering, specialized in mechatronic systems from the University of Ontario, Institute of Technology, Canada. And he develops regional partnership with universities and distributors from across the globe. So over 3 years, he worked with numerous reputable universities in more than 15 countries to modernize their engineering education. He's also involved with developing and implementing company strategy for international business development. So this is a nice complement to the previous university networks and presentations. Thank you and welcome, Mr. Thuvishan.
Thank you so much, Professor Rajeev and the full committee at Asian Institute of Design for having me. I'm excited to definitely jump in and discuss some of the future capabilities of virtual and remote labs. So with that, I will share my screen. And I really enjoyed the conversations that were had earlier by Dr. Gangadharan and Ms. Birte Heinemann, just because they prefaced my part of the discussion quite well. Quanser being an academic company, we have industrial ties, but we are fully aligned with the needs of academia, as well as specifically the interest for students and professors. So to maybe give you guys a bit of insight, ideally the focus of this discussion is to really illustrate how by providing students with your virtual or remote self-paced learning labs will really add a touch of realism for the actual lab environment or the learning environment. So before I jump in, I'd always love to start here. Quanser being an academic company, we've been in academia for over 30 years now. Our name actually comes from the roots of question plus answer. And this is derived from our founder, who was a professor at the University of British Columbia. Now, when you talk about experiential learning, when you talk about hands-on learning, the primary focuses are really around this concept of theory and understanding the concepts that are being taught in a textbook environment or in a classroom setting, but then really taking it to the real world and giving students hands-on experiences and what we love to call as bridging that gap. So Quanser develops laboratory solutions that are meant to be utilized for hands-on learning, and now both on the virtual as well as the real world physical domain in terms of learning tools that have been provided to institutions across the globe. We have regional partnerships specifically in India to touch on a few in various different states, and we have over 3,000 partnerships we have over 3,000 research publications on our solutions alone. So that really leads me to this next point. Why Quanser and digital experiences? As an academic company that's always focused our efforts on real-time control hardware, and we primarily focused in controls, robotics, and mechatronics solutions. We've developed real-time control capabilities, as Dr. Gangadharan was explaining, because of the many advantages that you get. For a student to be able to correlate what they are learning in real time and to be able to have their own physical solution or even virtual solution in this case to play with, the learning experience is invaluable. You start to correlate lessons that span beyond the textbook. So with that, Quanser has been developing for the past 2 years now, but thanks to the recent developments, we've been forced to release early our own new virtualized element. And I'm excited to share a bit of information with you guys shortly to come. And that's called the Quanser Interactive Labs, where we marry our expertise in the hardware space and now take a virtual element to combine those lessons that have been learned and to really provide a strong pedagogical approach for the learning process. So this has been a common question that we've received, and this is our good friend, Dr. Junjun Chan at York University here in Canada. But it's an example of the types of problems that professors and academics are facing. On a day-to-day, I get to work with deans, chairs, professors across a variety of different institutions globally. And this is the common sentiment that we're getting, where we have feedback that they have upcoming courses and they want to be able to modernize them and find ways that are applicable for online learning so that students, one, have a advanced or even enhanced learning experience. Professors aren't inundated by the tools that they need to utilize and learn to be able to deliver the courseware. And thirdly, something that's locally stored and accessible on any student's personal electronic device. So with that, I'm very pleased and excited to be able to demonstrate for you guys today the QLab's virtual experiment. So we have over 8 virtualized experiments to date, and that list is continually growing on our software platform called Quanser Interactive Labs. It's effectively the same Quanser physical hardware that institutions have been taking advantage of, but now virtualized. And the best part about this is currently it's a 12-month subscription, meaning institutions can buy in. They have a site-wide license, and it has a variety and varying degree of depth with regards to the topics that are offered. So here's a few examples of just 4 of them, but these are specifically around controls, robotics, both manipulator and ground robot. And then you go to the lengths of process controls for our couple tanks and mechanical design for our flexible link. So effectively, these are courses and teaching topics that have been structured in line with standard accreditation. For American bodies, it would be ABET. But as an example, you have this material that's now publicly available. You have resources that are now locally available. And you can now start to develop a self-paced learning approach that's fully instrumented and dynamically accurate to that of the real world. Now, the best part about all of this that I've not yet mentioned is we leverage industrial tools and academic tools such as MATLAB Simulink for the mathematical computational analysis that you'd be conducting. So when it looks to carry over from the real world where you had students who are learning in a lecture and lab environment, they were learning tools and coding in different graphical user interfaces, but specifically for engineering and in electrical engineering, you primarily leverage MATLAB Simulink, LabVIEW, maybe C++, Java, Python. And these solutions effectively open those doors and open those bounds, making it possible to leverage these software tools while still adding a relevance or a domain application that you can apply your learning to. So let's get an example going. Now, here's a sped up video, but what you're seeing on the top right is our physical cube. So this is the Quanser Cube Servo 2. It's a DC servo motor with an encoder attached, and there's 2 modules that are available. Right now, what you see at the top is an inertia disk, and there is also a rotary pendulum module, which I'll show you momentarily. But in this example, what you're seeing is a traditional process flow that a student might go through in a real physical lab. There's some type of computational analysis, they're doing a bit of mathematical modeling, and they're rapidly prototyping and tuning their controller to test. But now, what happens if we wanted to go beyond the lab and if we wanted to take it more into the virtual element or even into a remote element? What we've done is we've created our Quanser Interactive Labs platform that can be downloaded onto your local PC or your Android or iOS device. And you can now start to leverage these tools to be able to develop your algorithms, rapidly test them, and something that what we're calling is our sophisticated engineering workflow, where you can be tuning these controllers and then deploy them in the real world on a physical device to validate your assumptions. I do need to recommend and do need to state that Quanser being a hardware-based company first, the differences between the physical world and the real world, so the virtual world, need to be understood. You would never get into a plane that was only tested on simulation. You want to ensure that you have the fundamental skills by testing in a virtual element first, but then applying it on the real world and validating your assumptions to correlate the learning. So where does this go? What are the future capabilities and what are we seeing as an academic partner to institutions? Well, an example of this, and I'll give you 2, is with McMaster University out in Canada. We have developed, in partnership with them, a series-based program where they'll be leveraging our tools both on the virtual element as well as the remote capable element for their students to be able to do a variety of different applications that bode well for some of the most broad themes that are emerging today, but very innovative themes. So this is on the lines of IoT, cyber physical systems, 5G technology, smart grid technology, and network systems. So what you're seeing here is just a glimpse of the future capabilities. And what I really want to do is inspire you to think deeper in terms of the possibilities. So right now, Quanser leverages a 3D physics engine called Unreal. And that is how we've been able to depict our graphics on the top right. On the bottom right, what you're seeing is the actual physical counterpart that was built by Quanser. So you're seeing an algorithm that was tested in a structured environment. You're able to rapidly deploy your algorithm and tune it, and then actually test it in the real physical world. Well, what happens when you start to scale that approach? And that's exactly what McMaster University is doing. And I'll play this video twice just so you get a good glimpse. But this is a network system based around concepts around focus on cyber physical systems. But in this example, what you're seeing is a material process sorter. So a object drops into the rotary servo base. It identifies what type of material it is. It notifies the robotic manipulator that there's a material selected and waiting. The robotic manipulator needs to navigate to that position, manipulate it. So there's aspects of kinematics and dynamics, and then needs to deposit it in the correct location. After it's done so, it needs to communicate that to the ground robot, the mobile ground robot, which then goes and deposits it in the right storage bin location. So this was a recycling plant that McMaster University has tasked for their first year undergraduate students. So let me be clear, that's their first year. They're taking a very innovative approach by taking a project-based learning approach where they've truncated bite-sized pieces of this application, and they're tasking their students to go about understanding specific key concepts, but really thinking about the real world implications and the physical world applications in terms of the possibilities that are technically endless with a software platform like this. So as I mentioned, Quanser solutions have a beta-aligned curriculum for both the instructor and students. So when you're coming through your courseware, you're able to have a structured guided approach that's in line with standard accreditation in your specific country. But the biggest benefit here that I really want to highlight is the creative aspects. I've just given you a few examples of how a teaching application could be pursued, but where I really want to now take the conversation is more around the research applications or future capabilities, especially that might be of interest to students from AID. Now, when you're looking at virtual solutions or remote solutions beyond, I do have a good example here that I'd love to share for you. Our director of engineering calls this a simple lane keeping algorithm, which is beyond me, but Quanser has a 1/10 scale model of an autonomous vehicle. So we have an autonomous car that we've developed in-house that we offer for researchers and institutions globally. But what we wanted to do here in this case is we wanted to task our team to say, hey, what if we were limited on infrastructural space? What if IT concerns in terms of networking solutions or firewall permissions were a challenge for us at our institution? What could we do to help validate some of these assumptions in a research domain before coming to the lab and testing? How could we expand our capabilities and enable professors and students to take that technology back into their own hands and have a one-to-many learning experience? Well, we did just that. We took our lovely Q car, which you're going to be seeing zipping around in his basement, and we applied that same learning algorithm, that lane keeping algorithm, which is meant to drive as fast as possible, accelerate as quickly as possible, while trying to maintain a center distance in between the two lanes. Well, you're noticing a bit of tuning issues there. You're noticing a lot of error that's in this example, but he had the added ability of obviously having the physical device. We wanted to take the assumption to the point where, what if you didn't have the luxury of having the space? What if you wanted to test on a full-scale car? Would your institution have the roadways or even the infrastructural capabilities to support this? Well, now with Quanser Interactive Labs, we've made that possible. So we've applied that exact same learning algorithm, that lane keeping algorithm rather, onto our ground robot. Now, there was a slight tweak just based on the steering because we went from a 4-wheel drive to a 2-wheel drive. But ideally, the theoretical concept was the same. There's some aspect of utilizing the onboard sensors to track the center of the line, and then there's control algorithms in place to accelerate the ground robot as fast as possible while maintaining an optimal speed all throughout the navigational course. So the unique parts about this is, especially when you're bound by space or time requirements or even location, the opportunities are limitless with regards to the learning experiences. Now, this all leads me to this final culminating statements that I'd love to express to you. As we're working with professors and researchers globally, we're seeing the light at the end of the tunnel. We notice that there are novel and surprising ways to really empower students to have a great hands-on learning experience. And effectively, when utilized and paired with the right tools, you have the ability to take your learning to the next level and explore at your own pace while still conducting the same level of academic rigors that are required to receiving a tough degree like engineering puts you through. But the one thing that I love to express is, because we have the privilege and the vantage point of being able to work with faculty across the world and globally, we're really benefiting from the real-time knowledge of what's working and what's not. And what I am seeing personally, as well as what our company is seeing, is we truly believe that virtual experiences are here to stay. The balance of what we're calling a hybrid approach of both the virtual, remote, and physical labs will be coupled together to really enhance that learning experience and provide meaningful educational opportunities for students to take control of the education that they once might have been limited to because of lack of funding or lack of space or lack of infrastructural ability. Now, this is the exciting part, and what I wanted to convey to you today as well, where you have access at your fingertips today to numerous tools that are free or that your institution can purchase or procure to take advantage of. And don't let that stop you. Don't let there be any limiting barriers for your education. And we're living in very exciting times. So with that, I always love to express this statement where, because we have the privilege to work with some of the brightest minds in the world, we have this great feedback and relationship where we've cultivated a relationship where we're viewed as colleagues, not necessarily as vendors. 90% of our company are academics or individuals who went down the academic stream. So with that, I'd like to thank you guys for your time, and I hope I might have shared a few ideas that were new or novel to you. Thank you very much.
Thank you.
I'll hand it back to you, Professor Rajeev.
Thank you, Mr. Thuvishan. Now, we had 3 presentations. The floor is open for discussions. First, I would like to ask all the speakers some general questions so that we can generate a discussion among themselves. And in the meantime, I will try to look at the questions that has come through the chat function and question and answer function and take up some of the questions from there. One big challenge often with virtual based labs or simulation labs is how close it corresponds to the reality. Say, for example, Dr. Gangadharan showed in the beginning someone trying to learn swimming and cycling, etc. That's a very apt example of the challenges involved. At the same time, we know that aircraft pilots, before stepping into the actual cockpit, they train hours and hours in a simulator before they are entrusted with the aircraft. So often many of the labs are also like that, because labs require a lot of investment and a lot of trained personnel to oversee it, because equipments are very expensive. And if it is high voltage labs or something, there is a real danger of accidents and other calamities. So virtual labs has a big role to play in many situations before introducing them to the real labs. And in many cases, like in India, where lab facilities are absent in many of the campuses. One can use the facilities that are there already. So can you comment upon this issue of maximizing laboratory investment? But Heinemann also touched upon that aspect, and you showed the RFID lab where it is being shared too. So now it is a general questions, and I would like to listen to from all three your response to it, how we address this. Dr. Gangadharan, do you have some?
Yeah, sure. Good. In fact, what we felt when we started doing this is everybody will make fun of, can you do psychomotor skills using virtual lab? But an apt example was given by Professor Rajeev now. Look at a pilot. He has been trained in the without going to the cockpit. He has been trained so many hours before he even allowed to touch an aircraft. And we started asking people on the same way. Look at a civil engineering experiment called UTM, Universal Testing Machine, or as you said, a high voltage lab experiment where maybe corona effect is looked at, or conducting a test on dielectric potential of a material, things of that kind, or the breakdown voltage, etc. Obviously, we cannot ask the student to go there and do it every time. So before they go to the lab, they have to be trained on a simulation. Once they get trained on the simulation, the time taken in the actual laboratory could be very minimal. In fact, what Birte said is very correct. Here, by simulation, allows more students to get familiarized with the equipment and go to the equipment within a short span of time. Individual or maybe a couple should be able to do the experiment. In an Indian situation, we allow up to 6 students to do one experiment. I hope Thuvishan also agree with me that even in the other laboratories, they have a group of students doing the experiment. But if the simulations are done first, everyone knows what they are doing. Even though they are taking the reading from others, they will be knowing what it is. Otherwise, it will be noting down the reading. Because in a crowd of 6 people on a small machine, if somebody wants to do an induction machine, torque versus speed and torque characteristics, I'm sure that only 1 or 2 will be looking at the reading and rest all will be seeing what sound it makes. That's it. So here the virtual lab helps us in doing that pre-planning as well as pre-understanding before going to the real lab. This is when COVID is. I'm talking about either BC before COVID or DC, AC after COVID. It is not our BC and AC of this. Now we are in DC, that is during COVID. So during COVID, only way of looking at it is making this itself as an experiential learning. So after COVID, this will be a simulated experience. Go to the lab and do it much quicker or get more questions asked to the tutor or the instructor because they have already understood the procedure. You are not wasting time in the laboratory for understanding the procedure. All that is going to be the basic advantage. And of course, we are also able to share our costly equipment through online to other either less privileged or not having the same equipment, because some of the equipment which we are able to give online, the other version may be there in another laboratory, but they would like to have some specific advantage of using a better version here or maybe another attachment. All that is possible. That's how I look at the virtual lab and the real lab characteristics. Maybe Thuvishan can add and then it can continue.
Yeah, any comments to it from Thuvishan and Ms. Birte?
For sure.
I can just only agree with Mr. Gangadharan. We actually prepare our students for the real laboratory, and the students will more quickly find their way around in the real situation, in the real lab. They will come faster into the learning process, and we have good experiences And so we want to integrate the virtual laboratory more and more. And the next experiment we want to do is to connect also Italy and Parma, because both of them, they have different kind of RFID labs. So they get the hands-on experience in their own lab, but also are possible to use the RFID lab on the other part of the world and to get better insights into RFID technology and to do different kind of experiments. And that's a great opportunity.
Mr. Thuvishan?
Yeah, I'd probably just echo similar statements to Dr. Ganga and Ms. Birte. From Quanser's perspective, and especially working with different innovators globally, one thing that I always express is there's no substitute to the real world. You need to be able to test and validate in the real physical environment, and that could be through remote capabilities or on a physical solution. But the advantages that are at play when you start leveraging tools, online tools like MOOCs or virtual solutions, it's endless. To an example, to give you a few examples, like Dr. Gangadharan had just mentioned, you can have students pre-prepare for their lab. They could have done 5-6 hours of testing on that virtual environment before coming to the physical lab and testing for 5 minutes on the real physical solution. But ideally, you want to have a good ratio and balance. But one thing that I love to stress is from an institutional standpoint, it makes it very easy to have and support and justify solutions procured when you have economies of scale. You can have a virtual license or agreement to have some type of virtual platform that you can now provide to thousands of students and maybe only be required to purchase 3 or 4 pieces of physical solutions, making it more cost viable or cost effective when implementing the actual classroom setting.
Thank you very much. From this discussion, what I can see is that virtual labs are not really, one should not see it as a competition with the real labs like that. It is not that. It is a good complement to the real labs, because real labs are really expensive. Not all institutions can afford it. And you require a lot of personnel to operate a real lab. Every time a student group is coming for the experiment, you need support. Students cannot be left alone, often because of safety concerns and expensive equipment concerns, etc. And it is not on demand at any time like that. You have to schedule it, and only at certain time it is accessible, etc. So if you can add upon it the virtual labs, then even those without these lab facilities can use the top class facilities in some ways. So then you can add so many other things to it, and you are kind of enhancing the learning outcome even if there is a physical lab like that. So that seems to be the right direction to go, even if some of the universities can be well equipped. Still, there is a case for introducing more virtual labs. Then let me see if we have some questions in the chat or something like that. Yeah, there is a question. Are these labs, one is talking about virtual labs in India, are these labs only at IITs and NITs, or is there a plan to bring it to other institutions also? Ganga, can you explain?
Yeah. In fact, it's available for throughout the world now, because we have just kept it online and there is absolutely no login. Can you imagine me, Thuvishan, keeping my lab open, and my students said we are the best thief available, hence we are not worried about thieves from outside. And they said we have taken care of all the possible way of attacks which can come. In fact, we have a multi-layer architecture for the lab, which I have just demonstrated. Of course, what happened was these labs are very expensive. Then the ministry found it cannot be scaled for throughout India. So it was a pilot project we conducted, And in fact, it was done in 2010. Touch wood, it is working so far. And I have no replacement of any of the equipments. For the last 10 years, we have been running this equipment, and plenty of students, even from, in fact, many of my students are there in Germany and the other part. So they were also using. In the midnight, when I go to the lab, I see the pendulum swinging suddenly. So someone from other part of the world is using it. So that way, this is available for everyone. Everyone, not only in India, any place where they have a net connection and a computing device. And the computing device can be even a mobile, because some of the mobiles are as powerful as a laptop when we started with. When 2010 we started, the capability of that laptop was much lower than the present day mobile. So maybe the viewing area will be less, but those who are comfortable with using mobile in such environment, it can be used. So my answer to that question is, it is not just NIT or IIT. It is made by IITs and one NIT and few other institutions, but it is for the common learners throughout the world. And we are not charging anything for using or asking questions and commenting, or you can also build something on that and use it for yourself, or you can show it in the class. All that is available. That is the broad mindedness of a normal government setup in India.
Thank you, Ganga. We saw that you have a physical lab, and there are many equipments there that can be manipulated remotely by someone sitting in Canada or Sweden or some other place of the world. One can schedule the time and do the experiment like that. So that is there at the NITK. So do you have other such physical lab facilities that can be manipulated remotely in other places within that consortium of virtual labs?
Yeah, we have a setup in IIT Bombay, especially on control system, and IIT Delhi, we have on smart material in dynamics. And similarly, each institute, we started with one lab each, but presently the equipment cannot be maintained because the funding has stopped. But many of us are still somehow pulling on. I adjust some amount from other projects and make sure that my equipments are maintained and keep it running, because that is so close to our heart, because a physical lab being available online is something which is really good. In fact, one of the Quanser equipment we have provided for 2 PhD students from remote place, Northeast and state in India. And they came here for 45 days, did the initial setup and experiment. Then we allowed them to go back to their place, because they were teachers and they need to take classes at their place. And every day from 6 o'clock in the evening to 9 o'clock, we gave the slot. And we also provided one person to be here, because all these control system labs, if something goes wrong and we need some emergency switch. So we had 2 equipments and one person handled it, and 2 students remotely operated for more than 2 months to do the algorithm. And they have designed an algorithm, implemented it in the control system, and actually tested. Both items were from, in fact, from Quanser. It was provided by EduTech in India. Quanser was not directly dealing, it was EduTech, the company who provided that.
Okay, thank you. And Ms. Birte, DigiLab for you, I know that it is still running project. Will you open up some of the items that you have? Do you have some plans for opening it up for other users other than the consortium?
Yes, we do. There is one person working on a sustainable model, how to integrate it also in other universities. And I was not able to raise my hand, so I will ask now, because we are always discussing about how teachers integrate our labs in their own teaching, and if it's necessary to change their didactical methods if they want to integrate virtual laboratories. So I thought maybe Mr. Ganga has more insights, because they are longer working with virtual labs. Do you know how teachers integrate your labs into their teaching situations?
Thank you. Thank you for asking that question. That was really interesting because I think two of our papers are coming out on that, research papers. And wherein initially we were hesitant to see how the teachers will react. But more than the teachers, students started loving it and forcing the students to use it. I mean, the teachers to demonstrate it. And now we have Karnataka, the state where we are now in India. They have around 200 plus institutions, engineering colleges, which is a part of a university because we have something called affiliation. So all the colleges are nodal centers, and we have trained around 6,000 faculty members of that institute. We talk in terms of huge number because India is population-wise so huge. So 6,000 faculty members, we trained them for 5 days, and all of them have gone back and started using, hopefully started using it on the class. So this is for online classes. But before COVID, we have went around throughout India and given workshops. Around 300 workshops I have given personally throughout the length and breadth of India, wherein we saw how they were using in their classes. Of course, motivation of a faculty member is a basic assumption which you have made. As a faculty, I am motivated to teach. And we saw that those who are motivated and those who are not just doing it as a job, we found them using it extensively. So it was a very appreciating point which we got from students and faculty members saying that, look, my life has become simple. Complex concept can be easily demonstrated. This was the result we got. And hopefully you should see some IEEE conference papers coming out of all this activity.
Thank you very much. Now we are running out of time. This is an interesting discussion. We could have continued for a long time, but we are close to the end. Now, Mr. Chandra.
Yeah. Thank you all. Thank you all. It was really, interesting and informative one for most of the people to get access to the virtual learning environment, and especially the virtual labs being developed under the government of India, which can be used across the globe, irrespective from which university or college. I think that is very beneficial to most of the students and the faculties who can utilize and make it more, meaningful and useful for their point of view. And also, I think from the Quanser, the kind of products, and also from the consortium of European Union, which is coming up with those, I think that will also, provide required impetus for teaching and learning in the current scenarios. Thank you all to be, being part of this such a wonderful webinar. Thank you again, once again. Thank you, Professor Rajeev, to moderate and put up some good questions, which generally everybody wanted to know, because the things are not, when virtual, really will it work or not, when looking at only physical labs, but not the only one, but it depends on the kind of labs and the kind of courses we generally use also. So thank you all to be part of this, and hope to continue our relations and come up with some much more interesting stuff in near future. For all the participants, thank you all to be part of this webinar. We have a next webinar in this series of aided learning, which is more about moving from technology and things to design perspective, designing human engineering solutions, which is on 26th November. So you could think of how designs could be made it more humane in nature, and how what could be the solution for those things. So it is a very interesting one. Hope you all will join us in that webinar, and see you there on November 26th. Thank you all. Thanks once again for joining this.
Thank you.
Have a nice day.
Thank you and bye.
We keep in touch.
Yeah.
Sure.
Thank you so much.
Thank you.